All right, so we're doing some homework questions. Number 1 on worksheet 15. This was the, let's see, where is it? Polynomial inequality. So we have, looks like a quadratic, which is good news. That means we're going to be able to factor it to find all of our x-intercepts. But before you're worrying about factoring this, you're going to want to get it into standard form. So move everything to the left-hand side. I'm going to add the 2x over, so you got 3x squared. Add the 16x over. Oh, lovely. And now I got to think about how to factor that. So the good news is 3's prime. Oh boy. 4, 3, 6. Okay, let's do a positive 6 and a negative 2. That would work, right? Because that'd be 18 minus 2. So your 2 x-intercepts, which I know some of you were like, I just graphed it and looked for my x-intercepts that way. Awesome! Also another way to do it. But you do get 2 x-intercepts at 2/3 and at negative 6. So I really love when you guys do a hybrid approach of a sign chart along with a visualization for it. So if you know you have an x-intercept at negative 6 and at 2/3, and you know because of the nature of this quadratic that it was an up-opening parabola, it looks something like this. Not really that at all. But this is where your function is less than 0, and here is where your function is greater than 0, meaning above the x-axis or below the x-axis. So if I kind of translate that over to my domain sign chart, this should be a nice easy question. So go back to the actual question now. I want to know where it is greater than 0. So I'm worried about the green pieces. Starts here, ends here, starts here, ends here. Notice I use parentheses all the way along there because there is no equal to symbol on this problem, so you're not going to be using brackets. So this quadratic is positive from negative infinity, to negative 6, union 2/3 to infinity. I really, really, really like when you guys use these number line sign charts because it really displays the domain interval nicely for you. Some of you struggle with domain interval because we've talked about graph analysis so much that you start confusing domain interval with something else. So try that approach. What else you got? You want to stick to that worksheet for a minute? How about yesterday's homework with the rationals? Getting common denominators, x-intercepts, and vertical asymptote stuff. So that was worksheet 15, numbers 6 through 10. Anything give you trouble?
Let's do 1 through 10.
6. 6 is a great one to do. So number 6 is a rational inequality. Yeah. And right now in the form it's in, I'm not ready for anything. I'm not even ready to type it. So before you reach for your calculator, you got to remember that it has to have 0 on one side before you even touch the calculator. And I would like you guys to use this version on your calculator, so I want you to type a 2n plus 1, everyone please type, over 3n plus 1. Make sure you're using parentheses. And then you're going to subtract that other term over. Oh, well this is lovely. It's already got common denominators, okay? So I do want you to type this version in your calculator. Normally, my next step would be to get common denominators, but it already has them. However, I still think some of us might struggle on this step of simplification because you are subtracting this entire polynomial over here, and I think a few of us are going to forget to distribute that subtraction to the negative 1. So 2n minus 1n is n, and then 1 minus negative 1 is going to be a plus 2. So your numerator, when you simplify it, becomes n plus 2. Okay, but this, like I said, guys, this is the version that you do on your calculator. And this is the version that we investigate when we go to come up with x-intercepts and vertical asymptotes. So
the second one on the calculator?
Well, in theory, here's the problem. If I type this one on the calculator and I compare it to all my hard work of finding x-intercepts and vertical asymptotes, I'm just convincing myself that my wrong answer is still right if I made a mistake. So like, for instance, a lot of kids tell me the 1 and the negative 1 cancel out and they get n. So they're like, oh, I have an x-intercept at 0. And if they type that version in, it'll show that. But if they type the original one in, they'll say, oh no, I don't have an x-intercept at 0. Something must be wrong with some of my work somewhere. All right, so this on the calculator, this is the one we're investigating. Where actually is your x-intercept? Remember, that's your numerator equal to 0. So x-intercept at -2. So on your calculator, you should be able to confirm for me that you do see an x-intercept at -2. And then the other discontinuity, or critical point, I should say, would be any place where we have a discontinuity of a vertical asymptote. So the denominator equal to 0, I'm hearing we're going to have a problem at, oops, n is kind of weird, but yeah, I gotcha. N equals -1/3. Do you see a vertical asymptote that looks approximately at -1/3? Cool beans. All right, so now I'm going to need your help because I really do not know what this looks like. Other than I know you have a vertical asymptote about here-ish, and then you have an intercept right here. Does it do like this? Okay. And then the other branch is up here? Okay. And it never crosses through because there's no other x-intercept. Okay, cool. So the reason I like the picture of it is because that's going to help me quite a bit when it comes to this little sign chart. The two critical values were at -2 and at -1/3. Now, I would like you to put little stars on the -1/3. Why? That's an asymptote, which is going to be tricky when it comes to using a bracket or parenthesis. We'll get to that in a minute. All right. So here is a negative piece of the function. Here's positive. And here's positive. And I want to know where your function is less than or equal to 0. So I want to know about the negative part right here. So it'd be right here, huh? Well, it does say equal to 0. So at the intercept of -2, I am going to include -2 as a possibility for my answer because that's included. That's like an algebra rule, right? But are you going to be able to use the asymptote as an endpoint? So asymptotes always get parentheses regardless of whether it has an equal to bar or not. So the domain interval on this one, thank you for asking this one. This is a really tricky one. -2 to -1/3. Parenthesis on the 1/3 though. Huh? The 2. Yeah. Yeah. Isn't that awful? And so you were typing in that original version and you're like, it doesn't match, so you knew something was wrong. And that's what I want you guys to experience on a test. At least on a test, if you get to that moment and you're like, you could at least ask me like, hey, I noticed these don't match. And worst case scenario is I'll just say like, buzz off, kid, I can't help you. I don't think I've ever done that, but maybe. Be pretty cutthroat. Buzz off, child. All right, what else you got? Anything else on that worksheet? It is a hoot. Okay, so I'm going to pretend that's because you all tried it, had great success, and I'm going to move on. Anything else on your homework? We got a lot of page 138 practice. You guys had a little worksheet on graphing rationals at some point. If not, we can just start looking at worksheet 8 and 12, which is another part of your homework check. I'm waiting for my go-to girls. You got one, Scott? Yes, page 138. Is this the graphing rationals business? Okay, and then number 5. So, page 138, number 5. And this question, they want you to find domain, vertical, and horizontal asymptotes. And that's all they want you to find. So some of you go-getters out there like followed the yellow card to a T and did like every step. That's awesome. You don't have to find all of it though. So number 5, the function itself is numerator of 2x squared minus 4x plus 1. And then a denominator of, where are we at? X squared plus 2x. So I still want to follow my yellow card as closely as I can. And the first step on the yellow card says to factor everything. So if I were to factor this numerator, I think that factors nicely, doesn't it? Let's find out. Oh, no it doesn't. That doesn't factor at all, does it? Okay, well, there you go. It doesn't factor. So leave it. But the denominator factors. Could we factor an x out of that? Okay. So forget that denominator. Use this one instead. So they want to know domain and then any vertical and horizontal asymptotes. So domain is the next thing on the yellow card, and it says anything that would create your denominator coming out to 0 is a domain interruption. So whether it's a hole or an asymptote, it's still going to be a domain interruption. You guys can cheat. You don't have to do the domain intervals. You can say x can't be 0, and what else can't x be? X can't be -2. Very good. Now the next thing on the yellow card talks about whether there's a hole, and that would be if you saw any removable discontinuities like canceling. We don't have that, so I'm just going to forget and not think about that anymore. You do still have to consider it though, because if a hole cancels out, it's not an asymptote, so you got to watch out for that. Speaking of asymptotes, there's two vertical asymptotes here. Those two places of discontinuity are two different vertical asymptotes. Most important thing that you guys can remember today, when I ask you for an asymptote, whether it be horizontal, vertical, or oblique, I need equations of lines, okay? Don't just tell me 0 and 2 or whatever. You gotta write me an equation. And then it also asks you about horizontal asymptote. And that is where you do a comparison of the degree of the numerator to the degree of the denominator. You can go back to the original version though, guys. You have, you have 2x squared over x squared. Is that top heavy, bottom heavy, or equal weight when you compare the degree? That is equal weight. So equal weight means that you look at the coefficients, the leading coefficients, and your horizontal asymptote is at y equals 2 over 1, better known as y equals 2. That's all they want you to do on number 5. Don't go through all the other steps. What else you got? We're having that awkward moment where you guys tell me I did all my homework and checked it and I have no questions. Yeah. You guys must love last minute homework. Okay.
It's called an extreme sport.
Extreme sports. Oh, guys, you're making me so scared. Is this like a, we're just going to let it ride? We're going to let this ride until December, and then come January, like, we're all going to be new people. Be like, don't worry, Mrs. Bruiser, I got a New Year's resolution coming your way, and it's going to be, I'm going to do my homework right away, and I'm not going to let it.
New Year's resolution, but I've never followed through.
I will help you follow through with that. Oh, boy. Oh, boy.
PreCalc. I'm going to take it next semester in a second class, too.
Wait for the recording to go up.
It's awkward. Any more page 138? I'm really just looking at you guys because, you know. Bruiser's choice. All right. 24 is fun. You want to look at 24? It doesn't look really fun, but it's oddly fun. So this is page 138. Numbers 24. And they want me to find everything. So it's basically like follow your yellow card to a T. So, all right. So your function looks so silly and little. And you're like, oh, this won't be bad, right? It's not too bad. It's not terrible. All right, so following down the yellow card, first step in the yellow card says factor everything. And you're like, well, there's nothing to factor. So then step 2 says state your domain restrictions. That means I look at my denominators. X can't be -3. Awesome. Then I would investigate to see if there's any holes. There's no factoring that cancels, so there's no holes. And then that means my domain interruption is a vertical asymptote. You have a vertical asymptote where? Give me the whole equation. X equals -3. On your test on Friday, if you just write down vertical asymptote at -3, that's wrong, 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 wrong. All right, so the vertical asymptote after that on the yellow card, they want me to investigate whether we have an x-intercept. So x-intercept is where you set your numerator equal to 0 and do a little solving. So your numerator is pretty boring. It's just x to the 3rd. So if you solve that, you do get an x-intercept at 0, which also happens to be your y-intercept. Just for the sake of process, do you guys remember how we find a y-intercept? That's where you plug in x equals 0, which is incredibly boring on this function because it ends up being 0 over 3, which again is 0. Now, I kind of had a duh moment here. If the x-intercept was at 0, 0, that forces the y-intercept to also be at 0, 0, because that's the origin. But whatever, it goes through the origin. Okay. Now they want to talk to me about whether it's top heavy, bottom heavy, or equal weight, because I'm trying to determine if there's a horizontal asymptote. So you tell me, is this top heavy, bottom heavy, or equal weight? Top heavy. So there is no horizontal asymptote, but there is most definitely what we call an oblique. Okay. The oblique asymptote, known as the end behavior asymptote in this case, is found by doing division. It is your choice how you divide this, synthetic or regular. Synthetic is what most kids choose, and then kids mess this up. I know. You're like, how do they mess it up? Well, let me show you. So they divide by -3 in the box, and then they forget about the lead coefficient business. It starts off with a 1x to the third, but there's a whole bunch of trailing zeros. There's 0x squared, there's 0x, and there's 0 for a constant. And that's the thing that kids forget, and that's why they get this one wrong. Okay. So, bring down the 1, do some multiplying and adding. I don't even care about the remainder. Remember, the remainder is not part of your asymptote. It's just the quotient piece before the remainder. So then, it would just break my heart if y'all couldn't figure out how to put that back into polynomial form. Remember, guys, you took an x to the third and you divided it by an x. So this guy would be x squared. Now, it would super break my heart if you wrote down x squared minus 3x plus 9, because that would be wrong. Tell me why. It's not an equation. Jacob says you gotta throw a y equals in front of it. There's your oblique asymptote. I'm not gonna take this all the way to the graph. I want you guys to have fun with that.
Isn't that also the behavior?
Yes. Oblique and horizontal asymptotes are synonymous with end behavior equations. Yes. Yep, same thing. Yes, that question many of you missed on your test last week. That one.
Yeah, the one that I thought you were just looking for end behavior.
You wrote some very clever end behavior for me, and it was just not right, but I liked it.
But it was end behavior.
It wasn't right. It's a bummer. But it was end behavior.
You would know what the ends were doing if you looked at that and read that.
It didn't make mathematical sense, Daniel. I'm sorry. You just wrote gibberish. It was like complete gibberish. F of x approaches. I was like, what? Okay. So next time you're asked for end behavior on a rational, I'm looking for either a horizontal or an oblique. More than likely, it's oblique. All right. What you got? Anything else on the homework, or should we just look at worksheet 8 and 12? 8 and 12? All right. Worksheet 8, please. You guys are going to do 2, 4, and 5 for your homework check, which means I'm going to do 1, 3, and 6 with you. You're not doing side B, because we've already tested that section like twice. So unless you're doing a retake on 2.1, you don't ever have to look at worksheet B. So the directions on number 1 state, find the possible rational roots first, and then find all the rational zeros. So I'm doing number 1, you're going to do number 2 for homework. So starting with what y'all forgot the other day, and I'm hoping you remember how to do now. How do you create a list of possible rational roots? And I'll start you off with plus and minus. Maybe that'll
The lead coefficient, right?
something to do with the lead coefficient. You actually start with the constant. So what are all, big trick question here, guys. Factors of 1.
10.
1. And then you're going to divide it by all of the factors of your lead coefficient, which would be 1 and 2. Now this is not an okay list. This is like gibberish. So you need to go back and write positive and negative, 1 over 1, and 1 over 2. So how many possibilities did I just list out? 4 of them. Positive 1, negative 1, positive 1/2, negative 1/2. Okay. So now the next step is find all the rational zeros. So these are the actual rational zeros, or roots. This is a thing that you do on your calculator. And you use this list as inspiration. The only possible answers that you guys could give me here are answers of positive 1, negative 1, positive 1/2, and negative 1/2. So go graph it on your calculator, and then look. You could even confirm it using their trace or your table or something. This is cute because like no one's grabbing their calculator except for like 3 people. We're going to have that thing where you just wait for that nice kid to do it for you. And then all the pressure's on that nice kid. Because what if they get it wrong?
Then we're all wrong.
Did I just guilt you into opening your calculator?
Nope.
Who? Wait, oh dang it. Oh gosh, sorry guys. Hopefully you didn't copy what I've written down. Adam pointed out I didn't even write the right function. That's the function. Oh, well that works too. So I had the wrong function written down at first, my bad. On your calculator, do you see, is it 3 places where it goes through the x-axis? Can you tell me what they are based on this list? I think it's +1, -1, and I don't know what the other one is. It's either +½ or -½ +½ Okay, so there's a 0 at +1, at -1, and at +1/2. And those are all just confirmations from your calculator. Okay? You don't have to do any further confirmations. You don't have to do synthetic division or anything like that. Alright, so I'm going to take a peek at number 3. Because again, you're doing the other one for homework. The directions on 3 are a little different. It says, starts the same way, state the possible rational roots, and then they want you to find all zeros. So that means nice zeros, horrible zeros, and even imaginary zeros. So we're going to have to do a little bit of work on 3, okay? So f of x equals x to the third plus 7x squared plus 13x plus 6. So the possible rational roots is that plus and minus list. All right, ready? Give me all your factors for your constant. What are they? 1 and 2 and 3 and 6. Yeah. And then you're going to divide it by the lead coefficient factors. Well, that's super boring because you're just going to divide it by 1. So your list of possible rational roots is positive and negative, 1 or 2 or 3 or 6. So when you look at your calculator, if it's going to be a nice answer, it's going to have to be one of these. Yes, Daniel. Yeah, number 2.
Yeah. Somehow, we'll check the function, but it came out to with a 0.
There's only one 0, and then that's because the other 2 are not rational. There's only one rational root on that one. For number 2, yeah. So the other 2 are, I don't know if they're imaginary or rational, but they're not nice.
Okay.
So since they're not on that list, they're just icky.
Oh, yeah. So you don't rational?
You don't have to list them because the direction said find only rational zeros. Now the one we're working on now, number 3, says find all zeros. So when you guys go on your calculator for number 3, I think you only see one nice 0. Or maybe I'm wrong. I don't know. Is there just one nice 0? You might see 3 intercepts, but I think 2 of them are disgusting. What's the nice ones, guy? Okay, there's a 0 at x equals -2. Now, the other 2 seem to be decimals, right? Funky little things. There's no decimals in my list, so don't try finding them. They're gross. They're irrational. So now what you're going to have to do, and something similar happens on number 3, you're going to have to go through synthetic division to take your cubic and knock it down to a quadratic so we can handle it. So -2 goes in the synthetic box. We're going to set up synthetic division. So 1, 7, 13, and 6. And then after we go through synthetic division, first of all, what should my remainder be?
0.
Better be 0, otherwise Sky lied to me. She didn't lie. So these coefficients right here are my remaining quadratic. And guys, this is why you couldn't give me the other zeros. They are funky, funky, funky. This is not factorable. So how would you find zeros of a quadratic that you can't factor? You'd use quadratic formula, right? So quadratic formula states -b plus and minus square root of b squared minus 4 times a times c, and then all of it over 2a. Now, luckily, this is so irrational, and the radical doesn't even break down. So this is just square root of 13. So you're writing down 2 answers for me here. -5 plus and minus square root of 13 over 2. So that's 2 answers. But what was your other answer? Because this was a cubic. You're supposed to have 3 answers. And -2, yes, the nice one from your calculator. So on that section, because of the instructions, you had to give me all answers, even if they were gross. So you're going to do something similar on number 4 when you get to there. All right, let's take a look at number 6. Number 6. Now the directions say state the possible rational zeros again, but now they want me to factor, get it in beautiful factored form. So your function is 4x to the third plus 4x squared minus x minus 1. That is, oh, you know what? We actually could factor it with grouping. But let's not do factor with grouping. Sorry. I'm sorry. I just want you to practice something else, because this is something that shows up on your test, and I'm a little worried about it. Can you go ahead and graph this for me? Oh, real quick, though. Possible rationals would be plus and minus 1 over 1, 2, and 4, which would be positive and negative 1, 1/2, and 1/4. So when you go to look at your calculator, I think you can see a really nice 0 at, is it -1 or +1? +1? I don't know. I'm stealing your answer. I'm waiting for that nice kid, yes. I'm that kid who waits for the nice kid to do it, and then I yell at them when they get it wrong. -1? Okay, so there's a 0 at -1. So what I want you guys to practice doing is using synthetic division with that nice 0. And then I'll tell you why in a minute. Okay, so y'all just ended up with this quadratic, which is 4x squared minus 1. Now, sometimes kids take this all the way down to the solutions, and they get x equals positive and negative 1/2, because they're going to add the 1, divide by 4, and square root. That's great, but then they're like, well, now what? Because I get this from kids. I get x plus 1, and then x minus 1/2, and x plus 1/2. And they want to know why they have it wrong, because this is wrong. What's your lead coefficient on this factored form that you just came up with?
4 or 30.
1 times 1 times 1.
No, it's 30.
Your lead coefficient is a 1.
Cubed.
It's 1 though, right? 1x cubed?
Yes. Just keep spitting out answers.
Okay, I'm just going to keep yelling things. But your lead coefficient of the true problem is a 4. So here's what happened. In your math, in your effort to find a solution, you lost your lead coefficient. So when this question comes up on your test on Friday where you have to do something similar, just double check that your lead coefficient didn't go anywhere. And if it does, just stick a 4 on the front. Let me show you what else you could do though. A 4, better known as 2 times 2, right? Well, what if you took one of the 2's and distributed it to here and to here? Wouldn't you have x plus 1 times 2x minus 1 times 2x plus 1? I would claim that's the same polynomial. In fact, that's probably the more user-friendly polynomial, right? That's the one we're typically seeing, right? You guys never see factors of x minus 1/2. We never write it that way. So, as your teacher, I'll be able to tell whether you're equivalent to the right answer based on how you approach the question. Your job as the student is to make sure you didn't lose your coefficient in your work. Okay? That's fine. A lot of kids do that. They're like, I don't care, I'll lose it, I'll bring it back at the end. I'm fine with that, yes.
So which problems were we supposed to do on?
So you need to do 2, 4, and 5. All right, so quickly look at worksheet 12. We have a couple minutes here. You guys are supposed to do, you might want to circle them with me. 12A and B. So 23 and 24. We're doing 29. And then on the back of worksheet 12, you're doing 32. You're doing 35 and 36. You're doing 38. And then your homework check says to do number 41. There is no number 41. I think we meant 40. So please circle 40. So those questions are like I'm using my yellow card, right? 12A was 23, 24, and 29. Okay. Everything that we're having you practice here, guys, is hand-picked because it's on your test on Friday. Okay. Speaking of your test on Friday, when you walked in, you grabbed a review?
No.
So your homework is the majority of your reviewing, y'all. I think some of you are missing this step of the homework process. Homework is importante. We know this. I don't even know if I said that right. Probably not. Took German. All right.